Let's move on to question 15. Well, question 15 says, verify that the indicated function is actually a solution for differential equation. Question 15, checking to be the solution is y equals to x plus 4 times square root of x plus 2. A solution of the differential equation, y minus x, y prime equals to y minus x plus 8. As usual, we have left-hand side, we have right-hand side. So the left-hand side is this side, and the right-hand side is this side. Well, left-hand side and right-hand side for this explicit function must be equal to each other. So what you need the derivative. What's the derivative of this function? Y prime is equal to the derivative of x is just 1 plus 4 times. Here we have to take the derivative of the square root. The derivative of x plus 2 is just 1 divided by 2 times the square root of x plus 2. Well, we can simplify this as 1 plus 2 divided by square root of x plus 2. So let's substitute. On the left-hand side, you have y, which is x plus 4 times square root of x plus 2 minus x. This is your parentheses, times y prime, which is 1 plus 2 times 2 divided by square root of x plus 2. And this is your left-hand side. We want to check to see if this guy is equal to the right-hand side, which is y minus x plus 8. Your y is x plus 4 times square root of x plus 2 and minus x plus 8. So let us simplify each side and check to see if they're equal to each other or not. X minus x, 0. So you're left with 4 times square root of x plus 2 times 1 plus 2 over square root of x plus 2. And just going back to algebra, is this guy equals to? Here we can cancel out x and negative x. We get 4 times square root of x plus 2 plus 8. Well, let's take the common denominator between these two, which is square root of x plus 2. So you're left with 4 square root of x plus 2 times square root of x plus 2 plus 2 divided by square root of x plus 2. Well, we can simplify the square root and you're left with 4 times square root of x plus 2 plus 2. Is this guy equals to this? Well, if you factor out 4 here, you see that you get square root of x plus 2 plus 2. So as you can see, left-hand side and right-hand side are equal to each other. So what's the meaning of that? The conclusion is that y equals to x plus 4 times square root of x plus 2 is a solution of the differential equation y minus x, y prime equals to y minus x plus 8. Let's take a look at next question. We have question 20. Question 20 says, check to see if negative 2x squared y plus y squared equals to 1 is an implicit solution of the differential equation given as 2xy dx plus x squared minus y dy equal to 0. Very good. So here you have an implicit relation between x and y. What do we need? We need to find the implicit differentiation. Well, you could simplify this differential equation by dividing everything by dx or dy. So let us take a look at this. G of x and y equal to 0. This is the relation between x and y. Negative 2x squared y plus y squared is equal to 1. Use implicit differentiation from calculus. So here you have the product of two quantities in x and y. It means that we have to use the product rule. Okay, so you get negative 4x y dx minus 2x squared dy plus. The derivative of y with respect to y is 2y dy, and on the other side you get a 0. Very well. So what do we see here? The question is, can I simplify this relation? Can I divide up everything by negative 2? Of course, why not? It's an equation. You can divide everything, both sides, by the numbers or the constants that you have. So let us divide up everything by negative 2. These by negative 2. So what do we get? We get negative 4 divided by negative 2, which is just 2. We get 2xy dx. Negative 2 divided by negative 2, we get positive 1 plus x squared dy. And 2 divided by negative 2 is negative 1 y dy equals to 0 divided by negative 2 is just 0. Well, just compare this implicit differentiation by the ODE that you have. Comparing the ODE and the implicit differentiation, we see they are the same. The first term, 2xy dx, 2xy dx. The second term is x squared dy minus the third term y dy. If you factor out dy here, you get x squared minus y, which is the same as this term here. Now, how do you find explicit solutions? To drive the explicit solution, remember that the way that we define an implicit solution was that we can drive at least one explicit function that is a solution of the relation here, and it satisfies the differential equation. So to drive the explicit solution, we use algebra. So from this implicit relation, negative 2x squared y plus y squared equals to 1, Here we're going to use completing the square. And we're going to write it this way. We have y squared minus 2x squared y. Well, what do we need? We need plus minus x to the 4 equals to 1. So now if you take these three terms and combine them together, you're going to see you have y minus x squared equals to 1 plus x to the 4. It has x1, 2 as well. So what you're going to get, y minus x squared equals to plus minus square root of 1 plus x to the 4. So y is equal to plus minus x squared. So let me just write this here. So you get x squared plus minus square root of 1 plus x to the 4. So we derive two implicit solutions.